half of chronic pain patients leave clinics with their peptides ignored. Your own nerves manufacture compounds that rival external opioids, but only when somatic input hits the right rhythm. Pools et al. Mapped this in 2020. Messenger molecules spill from trigeminal endings and instruct your brainstem to release built-in opioids and regulators that gate pain. Those are your dynorphins and CCK. That is endogenous control. The dose is set by tissue conversation. Most clinicians never learned that vocabulary. That vocabulary gap shows up in the numbers. 40% of Americans report chronic pain, and most still get handed external opioids, while their internal pharmacy sits untapped. Terman and Sachetto traced how CCK in the periaqueductal gray controls whether the brainstem's descending inhibition fires or flatlines against incoming pain. Fields and Owen mapped the receptor architecture, mu, delta, and kappa, each tuned to different tissue conditions. Kalett proved the body manufactures stress-induced analgesia on demand when somatic timing is precise. Yet pain clinics still report 30 to 50% persistence rates because they count pills dispensed, not peptide tone. The dose was never meant to come from a bottle. Your heart rate variability reads peptide tone in real time. Each exhale that lengthens your interbeat interval signals vagal release, and that same branch resets pain thresholds through descending inhibition we saw earlier. Clinicians rarely connect the EKG trace to the pain chart. Autonomic mapping shows chronic pain states correlate with dorsal vagal shutdown, not just receptor shortage. The tissue is screaming because the nervous system thinks it is already dying. Why would evolution pay that cost to wire cardiac rhythm directly into spinal pain gates? The answer changes what measurable recovery actually looks like, and the numbers are stranger than the story we have been told. Peak human performance and total pain suppression share a single neural economy. When the prefrontal cortex surrenders priority during flow, the periaqueductal gray commands descending inhibition with a precision that external opioids cannot replicate. Endogenous dynorphin and beta-endorphin output surge alongside the brain's arousal signals, creating an analgesic envelope that outlasts the activity itself. The peptide cascade can peak at levels that would trigger regulatory scrutiny if they came from a pharmacy, yet tolerance never develops because the dose is tied to tissue conversation, not milligrams. But here is the number that breaks the model. In states of high attentional absorption, the body can suppress pain signaling by up to 80% using only its own receptor architecture. 80%. The calibration lives in the timing. Dose is secondary. And the timing is something no prescription pad can encode. Fixed-dose opioids trigger a receptor collapse that rhythmic peptide release avoids entirely. The cell literally pulls mu receptors inside and destroys them when stimulation stays constant. Endogenous signaling pulses, then clears, then pulses again, leaving surface density intact. The same in vivo trigeminal rhythm we saw earlier operates on exactly that principle. Within 1 month of standard around-the-clock dosing, the periaqueductal gray can lose over half its functional inhibition command. The drug still binds perfectly. The prescription is erasing the very receptor fields that natural peptide tone would have preserved. The chemistry has not run out. The syntax has collapsed. Poole et al. Showed CGRP release from trigeminal afferents functions as a timing signal that tells the periaqueductal gray whether to arm or disarm spinal gates. In chronic pain, the peptide is often still present, but its pulsed rhythm flattens into monotone. The brainstem treats that steady tone as background noise and withdraws density. Here is the pivot. Somatic input modality matters more than the molecule. Breath, load, and touch each generate distinct CGRP signatures that the PAG interprets as either threat or conversation. Kalett and Rasmussen proved endogenous stress responses can reawaken that syntax under precise conditions. The fix is rhythmic. There is no pill for timing, and the clinical protocol that restores it targets something no pain clinic currently scans. The gap between CGRP bursts carries an instruction no molecule can send. Mapped the release in 2020, yet the critical command lives in the millisecond silence after. When somatic input keeps rhythm, that pause tells the periaqueductal gray to stand down. Remove the pause and the gray never hears the stand down. Kalett and Rasmussen demonstrated that one disrupted endogenous stress response can flatten that silence into monotone for 6 months. The spinal cord does not read constant tone as louder pain. It interprets that as ongoing threat and starts building new receptor fields. A thousandth of a second gap decides whether the system resets or remodels. We know the month scale. We know the millisecond scale. The bridge between them is still missing, and the protocol that finds it does not scan tissue. It listens for silence. Silence gives the periaqueductal gray its only clear command to stand down. The protocol is already inside you. Load your breathing against precise resistance, track the interbeat interval, and wait for the recovery to arrive in discrete waves rather than a steady slope. Those plateaus are the gaps where endogenous tone rebuilds receptor density. One-time somatic session daily, trained at the wave crest, outperforms constant external dosing because it preserves the syntax we traced across 8 slides. The full research archive, with citations and operational templates, lives at jmthomasofficial.com. Your nervous system was never broken. It only lacked the right punctuation. Receptor density recovers in discrete plateaus, not steady curves. Train at the wave crest for 6 weeks, and the PAG begins reading somatic input as conversation again. The metric that proves it is a sudden stepwise jump in your interbeat interval variability, not a slow drift upward. That jump means your mu receptor fields have regained surface expression. 1 session daily, same time, same load. The full research archive lives at jmthomasofficial.com. The era of dosing by milligram is ending. Dosing by millisecond is what comes next.